In the realm of scientific inquiry, observations are the cornerstone. They involve systematically noting and recording data about natural phenomena. Whether we use our senses or sophisticated instruments, these observations are crucial for understanding the world around us and form the primary source of empirical evidence in research. When embarking on a scientific investigation, we start by defining our objectives and hypotheses. Objectives are specific goals or questions that the investigation aims to address, determining the focus and scope of our study. Then comes the hypothesis, a tentative explanation or prediction about the relationship between variables. It's based on prior knowledge and observations and is formulated to be testable through scientific methods. Utilizing scientific tools and instruments is essential in extending our capabilities to observe and measure. From thermometers measuring temperature to hygrometers gauging humidity, these instruments help us collect accurate and precise data, which is fundamental to drawing valid conclusions from our investigation. Setting up observation stations is a critical step. This involves choosing appropriate locations and configuring the environment or apparatus for the investigation. It's essential to ensure similar conditions across control and experimental setups and position instruments properly for accurate measurements. The frequency and duration of our observations are key. They should be consistent to capture changes over time and provide a comprehensive dataset. Moreover, maintaining consistency in observations ensures reliability, while meticulous recording of data is vital for later analysis. This includes noting not only the measurements, but also any relevant conditions or occurrences during the observation period. Data compilation involves organizing all collected data in a structured format, often using tables, charts, or spreadsheets. This facilitates analysis and interpretation. Graphical representations like graphs or charts help us understand trends, patterns, and relationships among variables. Trend analysis then involves examining the data for recurring patterns or directional tendencies over time, which can inform our conclusions and further hypotheses. Interpretation is all about understanding the meaning of our data in the context of our hypothesis and existing scientific knowledge. This is where we determine whether the data supports or refutes our hypothesis and understand the implications of our findings. Evaluation then assesses the overall process and results of the investigation, considering the validity and reliability of the findings and identifying any limitations or areas for further research. Finally, documentation and sharing of findings are crucial. Preparing a detailed report or presentation includes outlining the methodology, data analysis, conclusions, and any recommendations. It should adhere to scientific standards. Sharing findings, whether through scientific publications, presentations, or informal discussions, is a key part of the scientific process, allowing for peer review, collaboration, and the advancement of knowledge. Throughout this process, safety and ethics are paramount. Safety considerations involve recognizing and mitigating risks, using equipment properly, following protocols, and being prepared for emergencies. Ethical considerations, meanwhile, entail conducting research responsibly and with integrity, respecting subjects' rights and welfare, and considering the broader impact of the research on society and the environment.